Hello friends, this is Jim with Science Talk, and I want to bring you a study that was just published in the Journal of Paleoceanography and Paleoclimatology, which is a journal of the American Geophysical Union. And this study examines the emissions of carbon dioxide. And basically what the researchers are assessing, and give you some of the names of the principal researchers here. Philip Gingerich, who is a University of Michigan paleoclimate researcher. Gabriel Bowen, University of Utah geophysicist. Larissa DeSantis, a paleontologist at Vanderbilt University. These are the main principal investigators into this study, and what they're concluding is that CO2 could soar to levels not seen in 56 million years by the middle of next century. So now you say, well, that's what, 130 years away. Why should we worry? Well, we should, right? If we want to make the planet at least habitable for humans. So basically, and I'll lead off with the statement from Professor Gingerich. And he says that, yes, we're not going to be here, but that's really only 4 generations away. And he says that humans are pumping CO2 into the atmosphere at a rate 9 to 10 times higher than it was during a natural global warming event approximately 56 million years ago. That era, scientists refer to as the PETM, the Paleocene-Eocene thermal maximum. And that period was the Earth's warmest period since the extinction of the dinosaurs 66 million years ago. So we're basically talking about 10 million years after the dinosaurs, well, most of them, went extinct. According to the study, during that period, the poles were ice-free, and the Arctic was home to palm trees and crocodiles. Okay, so let's a little further background. Okay. In scenarios still not quite sure as to what happened, but have been about 10 million years after the dinosaurs went extinct, some natural event began to release ever greater amounts of greenhouse gases, principally CO2, also some methane. The sediments and fossilized fragments of the Paleocene-Eocene period is how we know this took place. Temperatures rose and settled at a global average of up to 7 degrees C higher than today's levels. Okay. Deep in the polar permafrost right now are fragments of tropical trees that flourish in the once balmy polar regions. Now, a little note of caution here. You have to take into account plate tectonics and the positions of the continents where they were. That many years ago, let's take Alaska for example. Alaska wasn't where it is now. It was considerably lower latitudes. So that you have to bear that in mind. It's not like it was so warm that these land masses were, within the Arctic Circle, say, or within the Antarctic Circle. It wasn't the case. The furthest latitude. But the fact is, they were warmer. When you have that much, if you have ice-free poles, that means you have open water that's absorbing heat. That helps keep the planet warm. The event was accompanied by the most dramatic extinction of marine life for more than 90 million years. The tropic seas reached almost to human body temperature, 37 degrees C, 98.6, dyslexic attack. land animals dwindled in size and migrated towards the pole as they evolved in response to the air temperatures. I'm working on a report showing that larger animals do not do well as temperatures increase. And the reason is very simple. The larger the organism is, the smaller the surface area to volume ratio is. So in other words, if I have a small animal has a surface area to volume ratio that's higher, that allows that smaller organism to dissipate excess heat. A larger animal cannot as readily dissipate excess heat. The animal becomes stressed and probably will not survive. So when you see higher temperatures, there's a tendency for smaller organisms to evolve. So that's one interesting caveat to that. And as you said before, the study says that this period the poles were ice-free. The Arctic was home to palm trees and crocodiles, apparently. And basically, they found fossilized evidence to make that assertion. I mean, science is not going to just pull things out of their back end. You know, they're saying it was home to palm trees and crocodiles because we have fossilized evidence for it. Climate scientists now know with a great deal of precision how much carbon has been released into the atmosphere since 1959. How do we know this? Isotopic fractionation. I did a lengthy video on that. We can basically, each molecule has a signature that tells if its source was anthropogenic or biological. So Professor Gingerich states that one way to appreciate the rates and risks of present-day carbon release to the Earth's atmosphere and oceans is to compare current emissions to those in Earth's history. The PETM raised global temperatures by 5 to 8 degrees C to the warmest temperatures since the extinction of the dinosaurs 66 million years ago. The PETM altered the Earth's carbon cycle, climate, ocean chemistry, and marine and continental ecosystems. So, I've done videos before in the past where I basically said that the key to understanding the present and what will happen in the future is to look at what happened in the past. And that's basically what these researchers are doing in this study here. They're looking at what happened in the past and making the extrapolation based on what we have data for that's happening right now. And as I just said, it affected the marine and continental ecosystem because the warmth caused major extinction of organisms in the deep ocean that are a key link in the marine food web. So what's happened here? Well, first of all, as you increase ocean water temperatures, the solubility of gases decreases. So you're going to have less dissolved oxygen. That's going to present the problem. Organisms are going to start suffocating. Also, probably was no deep water formation. So you're not going to be sequestering nutrients, carbon from the surface to deeper depth, and then the upwelling brings those nutrients back up to the surface. So you have no deep water formation most likely going on. It can create anoxic or anaerobic conditions at depth. It's a very possibility. Now, scientists do not know for sure what caused the spike in the CO2. We certainly know what's causing it now, don't we? The rates of carbon release that are happening today are really unprecedented. And that's a statement by Gabriel Bowen, University of Utah. We know, of course, that the increase in gases such as CO2, CH4, nitrous oxide is fueling climate change. We know that. The data is quite clear on that. Here is an interesting series of numbers I want to share with you to show you how much has been put into the atmosphere. And this is information, data that comes from the World Meteorological Organization. So, pre-industrial, around 1850 or so, right? Industrial Revolution probably started about 1850 by all accounts. 280 ppm, parts per million of CO2. 1850, 280. 10 years ago, 387. That's an increase of 107 ppm. 5 years ago, 398. Went up another 11. Last year, 408. Now, 412. So in less than, basically we're talking about what? 132 parts per million in 170 years. That's how much we have increased the level of CO2 in the atmosphere simply by burning fossil fuels. And that does not take into account how much has been absorbed by the oceans. If the oceans had not been absorbing as much as they have been, we would probably be extinct already. Humans would be. They have absorbed billions of tons of CO2. So at present rates, in less than 300 years from the start of all this, from 1850 and so on, we could make things extremely uncomfortably warm, that's another statement, for humans. Now, so we have all the CO2 there. What do we do about it? Experts said that to slow or stop carbon emissions and this anthropogenic warming, basically it's unnatural, of the planet, people, government, businesses must reduce burning fossil fuel and shift to renewable carbon-free energy. We know that already. Is it happening? Not fast enough. I just did a story about how an island off Denmark has gone completely green in supplying all its energy needs. It's a great first start. We need to expand that worldwide. So, Professor Larissa DeSantis states the following. It's not just about 100 years from now. It's going to take significant periods of time for that carbon dioxide to make its way back into the Earth's crust. It's not a short-term event. We're really committing ourselves to many thousands of years of a warmer world if we don't take action quickly. That's probably all true. Of course, now you have to take into account AMOC and thermal inertia. And you've heard me discuss that numerous times before. So, the other thing was that the researchers did confirm the evidence of mammalian dwarfism during the PETM era. And basically stating that this is an indicator of things to come. So, as we continue to warm the planet, look for the larger species to go extinct, and then there will be a push for smaller organisms. Just like the converse, when we have the ice ages, we have the large animals, because now the low surface area to volume ratio is a help to the organism to keep its internal heat, so that it can deal with the cold temperatures. Going the opposite direction now. So, if humans keep going as we're going right now, this will be very long term for the planet. There will be expect changes not only to what will happen to human civilization, but overall distribution, extinctions of organisms. We're definitely changing the planet. And as Elizabeth Colbert wrote in her brilliant book, The Sixth Extinction, I would love for her to do an update to include all this new information. But that would be part of it because of what we are doing. So, thank you for your time. We'll talk soon. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.